Welcome to this explainer. Today, we're going to tackle something I like to call the algebra wall. We're taking a true builder's masterclass approach here to completely strip away all that dense academic jargon and really master the fundamental tools of equations. Building directly on the foundational arithmetic skills from Lesson 2, this is absolutely the critical next step in your educational journey. If you've ever felt totally overwhelmed by letters mixing with numbers, well, you're in the exact right place. We're going to break it down tool by tool, so let's just dive right in.
Let's start with a really crucial question that our source materials highlight. Why do so many students hit a wall in intermediate mathematics and simply start faking it? You know exactly what I mean, right? Nodding along in class, hoping the teacher doesn't call on you, and just trying to memorize steps without actually grasping the underlying logic. The source material hits the nail on the head with this quote. Algebra is where most students either build real confidence or quietly start faking it. This specific lesson on algebraic manipulation is literally the ultimate turning point for your entire mathematical journey. It's not just about passing a quick quiz, it's about not being left behind for the next 4 years of math. A student who doesn't fully own these basic skills will spend the rest of the year just kind of getting by on equations they don't actually understand. Every formula rearrangement, every complex quadratic, they're all built straight from the basic skills we're going over today. Our curriculum sources use a 10-minute cold diagnostic test to establish your absolute baseline of what you've got to conquer before we can even think about moving on to complex equations. It's taken completely cold, no warm-up, no calculators, because true mastery means knowing this stuff under pressure. It tells you exactly where the immediate cracks are in your foundation. If you're struggling here, it just means we need to fix the basics before we start building the house.
To tackle all of this without the cognitive overload, we have broken it down into 5 distinct modules: swapping numbers with substitution, sorting variables through like terms, breaking out by expanding, grouping up with factorizing, and finally, the mastery check.
All right, Module 1, swapping numbers, also known as substitution. Substitution is simply replacing every letter in an expression with a given numerical value, always using brackets if the value is negative. Think of it as the mathematical equivalent of swapping a player out in a sports game. You take one player off the field and you put another one in their exact same position. By redefining the scary academic term into plain English, the rule becomes incredibly simple. You replace a letter with a number. But, and this is a massive but, you absolutely must always use brackets if the value is negative. Provided you apply the strict order of operations, or BODMAS, from your foundation arithmetic, you really cannot go wrong here. That means brackets and powers happen before multiplication, every single time.
Now, this tiny missing bracket is the villain behind like 90% of all the algebra mistakes you're going to make this year. It looks super innocent, but it will absolutely ruin your equation. Just compare the incorrect versus correct examples. If a is -2, the expression -a² does not evaluate to a +4. If you forget your brackets, you'll calculate it as -2² getting a +4. But if you properly substitute using brackets, you get negative, bracket, -2, close bracket squared, and that correctly evaluates to a -4. It is a complete game changer. Walking through these fully worked substitution examples from our source text, you can see exactly why we obsess over brackets as things scale up. We start by evaluating a simple expression with x and y, and then we take that exact same logic and apply it to a real-world geometry formula, like the area of a trapezium, where area equals half of a plus b times h. Precision is totally non-negotiable, from the simple to the complex. Notice how every single negative substitution is safely hugged by a pair of brackets before any multiplication or squaring ever happens.
Moving right along to Module 2, sorting variables, or collecting like terms. If substitution is swapping players, collecting like terms is simply sorting your groceries. You wouldn't mix your apples and oranges in the same bag at the checkout, right? You put apples with apples and oranges with oranges. So the crucial point here is defining what an apple actually is in mathematical terms. Like terms are terms that have the exact same variables raised to the exact same powers. An x is definitely not the same as an x². Only identical variable profiles can be combined by adding or subtracting their coefficients. So let's say we need to simplify 5x plus 3y minus 2x plus y. The 5x and the minus 2x group together to give us 3x. Meanwhile, jumping over to the y terms, the 3y and the y group together to give us 4y. We're perfectly sorting our algebraic groceries without mixing them up. 3x plus 4y is our final answer. Clean, sorted, and simple. Okay, Module 3, breaking out, better known as expanding brackets.
If you want to think like a builder, expanding brackets is the process of physically dismantling an equation to its bare, individual parts so you can work with them out in the open. Breaking down the operation step by step completely removes the intimidation factor. You're just distributing the multiplier to every single piece inside the bracket. For expanding 3 times the bracket x plus 4, first you multiply the outside 3 by the x, getting 3x. Second, you multiply that outside 3 by the positive 4, getting 12. Bring them together and you have 3x plus 12.
But hey, you really gotta watch out for negative multipliers. This brilliantly illustrates exactly why your foundation in directed numbers from Lesson 2 matters so much. When you have a negative multiplier, like a -2 sitting outside the bracket x minus 5, you have to be incredibly careful. A negative multiplier hitting that -5 inside the bracket actually flips it to a positive 10. So the expansion is -2x plus 10. If you don't have those basic directed number rules locked in, this step will trip you up for sure. Which brings us to Module 4, grouping up or factorizing.
If expanding was dismantling the structure, factorizing is simply the act of building those brackets back up. Think of it like bagging the groceries back up based on what they share. You act like a detective looking for the biggest common denominator. Look at factorizing 6x plus 9. What's the biggest number that divides perfectly into both 6 and 9? Well, it's 3. That's our highest common factor. We extract it, put it outside the bracket, and then divide our original terms by 3 to see what's left inside. 6x divided by 3 is 2x, 9 divided by 3 is 3, so we get 3 on the outside and 2x plus 3 on the inside.
What's really fascinating here is how expanding and factorizing are literal mirror images of one another. You can always check your factorization by simply expanding it back out. It's a foundational concept that traces all the way back to basic prime factors in Book 2 of our sources. Just a quick check, though. The highest common factor of 12 and 18 is 6. Before applying this to complicated algebraic variables, you must be rock solid on finding the numerical highest common factor. You lean on the exact same prime number arithmetic you've already mastered. This matters because mastering the pure numbers right now prevents complete cognitive overload when letters get thrown into the mix later on. If you can do the numbers instantly, algebraic factorization will just be adding letters to a skill you already own. And finally, Module 5, the mastery check. This answer key for the mixed mastery test represents the ultimate pass bar for our lesson today. It tests substitution, like terms, expanding, and factorizing. Because, as the source rules for this program dictate, nobody moves to the next topic until they have actually earned it, and they must do it entirely without a calculator. We don't settle for "I sort of get it." If you make a silent sign error here, missing a negative or misplacing a bracket, you're going to drag that exact same error into every quadratic equation, every simultaneous equation, and every single statistics formula you encounter for the rest of the year. So, here is the big question. Have you earned the right to move on? Take a hard look at your diagnostic and practice results and ask yourself, are you ready or are you just faking it? Can you execute these tools flawlessly under pressure? Remember, every complex quadratic equation you'll ever face is just a combination of the basic tools we use today. Master these and you master algebra. Skip them and the wall only gets higher. So what's it going to be?